When I first built the van, I decided I wanted to have air conditioning. This was supposed to be my daily driver when the Corrado was broken, and then I had to get a winter daily because the van was too valuable to trash in the wintertime. In either event, daily drivers require frosty cold AC, and the Vanagon was no exception. I originally tried to do AC in here 10 years ago using a 7,000 BTU room AC unit. It worked rather poorly, and I was able to take away from it 3 key learning experiences. First was that these room AC units are terribly inefficient, especially when they are the single ducted model, which was what I had. Some of the chilled air is then used to cool the condenser coil, and that hot air is then rejected outside. This means that the air needs to be replenished from somewhere, which means that hot air gets pulled in from outside. Technology Connections did a great video explaining this in detail, and I recommend checking it out. I'll also be sure to put a link down next to the like button in the description below. At the time, I was using a room unit that was somewhere around 7,000 BTU, and this drew about 900 watts of 120 volts AC to power, which translated to 100 amps of 12 volts DC draw. This quickly ruined an alternator when I used one alternator to power that and the rest of the van. I thought about installing a second alternator, which would have solved the problem, I think, combined with using a double ducted or mini split type unit. While a 7,000 BTU room air conditioner may work well for a 12 by 12 room, this is utterly terrible for vehicles. To cool a small house, AC will need to be somewhere around 24,000 BTU or 2 tons of cooling. A Chevy Suburban can have air conditioning that exceeds 60,000 BTU or 5 tons in capacity. The reason for all the extra tonnage is because the sun is a powerful adversary to keeping things chilled. At 1200 watts per square meter, the sun's rays pierce metal and glass with ease. Since the van is half glass, this meant that my electrified solution would be terribly anemic at its very best efficiency. When I swapped the Subaru EG33 engine in, I kept the components for the air conditioning from the SVX I harvested the original engine from, and kept much of the stock van stuff as well. In the two-wheel drive 7-passenger Vanagons, as mine originally was, the evaporator unit was overhead near the center of the van between the 2 front seats and the rear area. I have seen some Westphalia Vanagons where the evaporator unit is located in the very back, which I decided to mimic because I liked having all that overhead room up front. When you don't have anything mounted near the ceiling, it really makes a difference when it comes to feeling spacious. My original one was falling down, so I removed it all, knowing that I would replace it with something else later on. One night, browsing around on eBay, I found an evaporator box that is a sort of universal fit, and it was a really good price. I decided to give it a shot on my van. The BTU rating was somewhere around 35,000, I think. The evaporator was large, much larger than something you would see in a standard heater box located inside the dash panel. At the time, I was unable to buy the newer model condenser that is available from GoWesty, so I was forced to locate a factory condenser and run that for the time being. The factory condenser is a serpentine-style heat exchanger, meaning that there is one long continuous tube coiled up that refrigerant flows through. The newer style condenser that is more efficient is a parallel flow condenser. These have multiple tubes in rows that carry refrigerant from one side of the heat exchanger to the other, and is the style offered up from GoWesty. After waiting for more than a year, I was finally able to secure one of my own, though I was a little disappointed when it showed up and the condenser was anything but straight. The price was right though, so I cannot complain too much. Another thing that needed an upgrade was the radiator fan. When I didn't have air conditioning, the early style 3-bladed 12-inch fan worked okay for keeping the extra 180 horsepower worth of engine cool. When I had studied other EG-swapped Vanagons, people who did have AC found they needed to upgrade to keep things cool, and I was finally running up against this with my newfound air conditioning upgrades. The original fan was 300 watts on high speed, and this new one is 500 watts. This fan shroud is from a diesel Vanagon, and the fan itself is 14 inches in diameter instead of 12. I am sort of apprehensive about how tight the fitment is going to be because the 12-inch fan takes up almost all the space in the cavity available for the fan to reside in. I feel like things are going to get tight when it comes to installation time. With the other 2 items a requirement on the upgrade venture, it only makes sense to complete the thermal transfer sandwich with a new radiator. This is a Behr unit which actually makes the OEM radiators for the Vanagon. These come with the official VW part number and logo scratched off of them. I decided to put some epoxy over where the plastic had been gouged out to avoid potential failure of a weak point later on down the road. I wasn't satisfied at all with the brackets that came with the condenser in the GoWesty kit. The brackets attach the condenser to the van body, which is different than the factory mounting which attaches it to the radiator. For some people, I could totally see the GoWesty kit being the better option, since you might be able to get away with not having to discharge the AC should you need to service the radiator or fan. The problem that I see with this is that it leaves a larger gap between the condenser and radiator, and without any kind of air dam or ducting to funnel the air being sucked into the radiator across the condenser beforehand, this can greatly affect overall AC system efficiency and performance. I decided to make my own brackets, which would only take an afternoon. I started with a CAD template and cut out 4 similar pieces of an old server case that I had laying around. Next, I bent them up and drilled the bolt hole out, having a tab that also inserts into the slot to secure all 4 corners. You'll notice that the condenser is closer to the radiator at the end that doesn't have the fittings. This is intentional, as there is a crash beam that essentially cuts the radiator into a top and bottom section. On the older vans, the condenser was 2-piece. On the later vans, it was a 1-piece condenser. One thing I've realized, though, is that when you have some space between the beam and the heat exchangers, more air can get in and efficiency is increased greatly. That is why I think I've never had any problems before I had the AC, because I had the condenser removed as well. There was almost 2 inches between the face of the radiator and the crash beam, thus allowing much greater airflow throughout the entirety of the radiator. To finish this installation, after bolting the condenser down, it was time for sealing up any air paths between the condenser and the radiator. To maximize efficiency of our newfound parallel flow condenser, we needed to use some foil tape or sheet metal to seal all the air gaps. This forces all cooling air to pass through the first heat exchanger before the radiator, and then finally the fan. With the exchanger sandwich successfully assembled, it is time to move on to what we will be doing for electrical controls, which requires a separate video. Until next time, stay safe and build your dreams.